the world consumes a significant volume of lobsters annually. Statistics indicate that over 150 million kilograms of these crustaceans are brought to market each year. This figure represents a considerable demand for a creature that once held little culinary appeal, primarily sourced from specific regions. The journey from ocean floor to dinner plate is complex, involving intricate biological processes, historical re-evaluation, and a large-scale commercial operation. This sustained consumption illustrates a remarkable shift in perception and an efficient, if sometimes challenging, supply chain. The majority of lobsters consumed originate from the North American continental shelf. The American lobster, Homarus americanus, is the primary species driving this industry. Its habitat stretches from Newfoundland and Labrador in Canada down to North Carolina in the United States, thriving in the cold, nutrient-rich waters. Key fishing grounds, such as those off the coast of Maine, yield millions of individuals each year. This particular species is distinguished by its robust claws and often vibrant coloration before cooking, making it a recognizable and economically significant marine resource. The American lobster possesses a notable lifespan, with individuals capable of living for more than 50 years under ideal conditions. Their growth is a continuous process, punctuated by molting, allowing them to shed their restrictive exoskeletons. The largest recorded American lobster was an extraordinary specimen caught off Nova Scotia, weighing 20.14 kilograms. Such a size indicates a considerable age and a life spent successfully navigating the ocean environment. These creatures exhibit resilience, adapting to changing conditions over decades, a testament to their evolutionary success. Growth in lobsters is achieved through a process known as molting. As the lobster grows, its hard outer shell, or exoskeleton, becomes too small. To accommodate further growth, the lobster sheds this old shell, emerging with a soft, new exoskeleton underneath that rapidly expands and then hardens. This period immediately after molting leaves the lobster particularly vulnerable to predators, as its defenses are temporarily compromised. They seek shelter in crevices or under rocks during this critical phase. The frequency of molting decreases as the lobster ages, with mature individuals molting less often. The reproductive cycle of lobsters is methodical and protracted. Females do not mate for life, but their gestation period is significant. Following successful mating, female lobsters carry their eggs, often numbering in the thousands, on the underside of their tail for approximately 1 year. This extended brooding period ensures the eggs are protected until they are ready to hatch. Once hatched, the tiny larvae are released into the water column, beginning a new, perilous phase of their existence, largely at the mercy of ocean currents and predators. After hatching, lobster larvae float in the water column for a period of 4 to 6 weeks. During this pelagic phase, they undergo several developmental stages, changing in form as they grow. However, this is also a period of extreme vulnerability. The vast majority of these minute organisms fall prey to other marine life or succumb to environmental factors. It is estimated that less than 1% of lobster larvae survive to reach adulthood and settle on the ocean floor. This high mortality rate is a natural control mechanism, ensuring a sustainable population without overwhelming the ecosystem. Once past their larval stages, juvenile and adult lobsters adopt a benthic lifestyle, meaning they live on the ocean floor. They are opportunistic feeders, consuming a varied diet of fish, crabs, mussels, and other invertebrates. Their powerful claws are adept at crushing shells and tearing flesh. Lobsters are also known to be cannibalistic, especially when confined or when a vulnerable, freshly molted individual is present. This behavior is a significant challenge for any attempts at large-scale aquaculture, demanding careful management of their environment to prevent loss. The perception of lobsters has undergone a remarkable transformation over centuries. In the 17th and 18th centuries, these abundant crustaceans were not considered a delicacy. They were often viewed as a food for the poor, used as fertilizer for crops, or served to prisoners and indentured servants. Their sheer numbers, especially washed ashore after storms, made them an easily accessible, if undesirable, food source. This low status stands in stark contrast to their current position as a luxury item, reflecting a significant cultural shift in food preferences and economic value. The mid-19th century marked a turning point for the lobster's culinary status. Improved transportation networks, particularly the expansion of railroads, allowed live lobsters to be shipped inland, reaching new markets away from coastal areas. This increased accessibility, combined with growing urban wealth and changing culinary trends, began to elevate its image. What was once a common sustenance for coastal communities gradually transformed into a symbol of fine dining. The rarity and freshness associated with inland delivery contributed significantly to this rebranding, establishing its place as a desirable delicacy. With rising demand, mass harvesting of lobsters commenced in the 1840s, fueled by the advent of canning technology. This allowed lobsters to be processed and preserved for wider distribution, significantly expanding the market beyond fresh consumption. Around the same time, the first lobster pounds emerged in the 1800s. These enclosed coastal areas or man-made tanks allowed fishermen to store live lobsters for extended periods, regulating supply to meet demand and ensuring freshness, particularly during off-seasons. This marked the beginning of a structured, industrial approach to lobster fishing and distribution. The primary method for catching lobsters has remained largely consistent, the use of traps, often referred to as pots. Historically made from wood and later incorporating wire mesh, these traps are designed with one-way entrances that allow lobsters to crawl in but make it difficult to escape. Bait, typically consisting of herring, mackerel, or crab, is placed inside to attract the lobsters. These traps are set on the ocean floor, often in lines marked by buoys, and form the backbone of the commercial lobster fishery. The design leverages the lobster's natural scavenging behavior. Lobster fishermen operate on a regular schedule, typically checking their traps every 1 to 3 days. This routine ensures the catch is retrieved, traps are rebaited, and any undersized lobsters or protected females are returned to the sea. The precise timing depends on factors such as weather, currents, and the density of the lobster population in a given area. It is a labor-intensive occupation, requiring knowledge of the local marine environment and adherence to strict regulations. The cycle of setting, checking, and hauling defines the daily life of a lobster boat crew. To ensure the sustainability of lobster populations, various conservation measures have been implemented. Traps are equipped with vent escapes, small openings that allow juvenile lobsters to exit, preventing their capture. Measuring gauges are used on board vessels to ensure that only lobsters within legal size limits are kept. Perhaps most critically, egg-bearing females are V-notched on their tail fin before being released. This permanent mark identifies them as breeding females, protecting them from capture for life, even after they have shed their eggs. These measures help maintain a healthy breeding stock. Beyond physical conservation tools, the lobster industry operates under comprehensive regulatory frameworks. These include minimum and maximum size limits, designed to protect both juvenile lobsters and the largest, most prolific breeders. Additionally, trap limits are enforced. For example, in Maine, a single fisherman is typically limited to around 800 traps. These regulations are critical for managing fishing effort, preventing overfishing, and ensuring that the resource remains viable for future generations. Compliance is mandatory and enforced by authorities to maintain ecological balance and economic stability within the fishery. Despite conservation efforts, the lobster industry faces contemporary challenges. Shell disease, a bacterial infection that erodes the lobster's exoskeleton, has become more prevalent, particularly in warmer waters. While not typically harmful to humans, it can weaken lobsters and reduce their market value. Another environmental concern is ghost fishing. This occurs when lost or abandoned traps continue to catch lobsters and other marine life, which then die, creating a perpetual cycle of unnecessary mortality. Efforts are underway to retrieve ghost gear and develop biodegradable trap components. Climate change presents an overarching threat to lobster populations. Rising ocean temperatures directly impact lobster physiology and habitat. Warmer waters can accelerate the spread of diseases like shell disease and alter the distribution of lobsters, pushing them further north. Ocean acidification, a consequence of increased CO2 absorption, makes it harder for lobsters and other crustaceans to form and maintain their shells, potentially impacting growth and survival rates. These large-scale environmental shifts necessitate adaptive management strategies and broader climate action to protect the future of the species. The lobster industry constitutes a significant economic engine for coastal communities in North America. Combined, the United States and Canada's lobster fisheries contribute an estimated $1.5 billion annually to their respective economies. This valuation encompasses not only the direct sales of lobsters but also the entire supply chain, including boat manufacturing, bait suppliers, processing facilities, and tourism. Thousands of jobs are directly and indirectly supported by this industry, highlighting its vital role in the regional economies and the livelihoods of countless individuals. Once caught, lobsters embark on their final journey to consumers. The majority are shipped live, packed on ice or in specialized containers to maintain their vitality. This meticulous handling is crucial for ensuring freshness and quality upon arrival at restaurants, supermarkets, and processing facilities. Live shipping allows for maximum flexibility in preparation and commands a higher price. Some lobsters are immediately processed, but the preference for live delivery underscores the premium placed on the experience of fresh lobster, often cooked moments before consumption. At their destination, lobsters are prepared in various ways to extract their prized meat. Common methods include steaming or boiling, which cook the meat quickly and evenly. Once cooked, the meat is primarily found in the tail, claws, and smaller sections within the knuckles. The vibrant orange-red color associated with cooked lobster is a result of pigments in the shell reacting to heat. While often enjoyed simply with butter, lobster meat is also incorporated into a wide array of dishes, from bisques to rolls, showcasing its versatility and rich flavor. Despite the high demand and economic value, large-scale lobster aquaculture remains a difficult endeavor. The primary obstacles are the lobster's inherent cannibalistic nature, which requires individual housing or complex separation systems, and their slow growth rate. Lobsters take several years to reach market size, making the return on investment protracted and capital-intensive. These biological and economic factors have largely prevented the development of a commercially viable aquaculture industry for lobsters, contrasting with many other seafood species that are extensively farmed. The lobster industry has made considerable strides in sustainable practices, particularly in North America. Many fisheries, especially in Canada and the Northeast United States, have achieved certification from organizations like the Marine Stewardship Council, Master of Science. This certification indicates that the fishery is well managed, minimizes environmental impact, and maintains healthy stock levels. These efforts combine traditional knowledge with scientific data to adapt fishing practices, demonstrating a commitment to long-term viability and ensuring that future generations can continue to harvest and enjoy this valuable marine resource responsibly. The future of the lobster on our dinner plates is inextricably linked to the health of our oceans. While robust conservation and management practices are in place, external pressures from climate change, habitat degradation, and emerging diseases pose ongoing threats. Continued scientific research, adaptive regulatory policies, and international cooperation will be essential to navigate these complexities. The journey of the lobster, from the deep, cold waters to its global status as a culinary icon, is a testament to nature's resilience and humanity's evolving relationship with marine resources, demanding vigilance for its continued existence.